This lesson is for Advanced Algebra, Lesson 1-4, on the graphs of functions. Since this is one of our first lessons of the year and of the chapter, our main focus is going to be on two main ideas as it relates to graphs, and that is domain and range. The domain is the set of the allowable values for the independent variable. Those of you who are visual learners, on a graph you want to think about it in terms of the width or the horizontal portion of the graph. The range is the set of values for the dependent variable that result after plugging in all possible substitutions for the independent variable. So the dependent ones, or the range, come from the independent one. But basically what I have kids remember is domain is independent with width, range is dependent, and you think about the height of the graph. It's easier to learn domain and range when you look at an actual graph or some pictures. So let's look at the yellow graph here on the left. There's a line that starts on the y-axis and descends down to here. And what we want to do is revisit our formula or our definition, as well as the hint here on the width of the graph. So remember that the domain is related to the x, or the horizontal portion of the graph. So you can tell here that the x's begin at 0 horizontally and travel all the way through 8 horizontally. So just in terms of keeping the numbers in your mind, the domain, or the d here, is going from 0 to 8. The range is going to be the y values, and so you want to look at the graph vertically. The lowest that the graph gets in terms of the y value is the 2, and the highest that it gets is the 5. So the range of the graph goes in between 2 and 5. Most students are able to come up with this fairly easily or on their own as they look at the graph. What I want students to work towards is the proper notation for how to write domain and range. Officially, when you do domain and range, you want to enclose it in squiggly brackets. Many students have difficulty drawing those, so just do the best you can. Try to think of it like a 3 with an extra hump. The next piece you'll write for the domain or the range is what variable you're working with. So the domain is the independent and the range is the dependent. In this case, we're using x and y. So we'd say x for domain, y for range. Then there'll be a vertical bar there, and that bar, when said aloud, is said as such that. So we're saying the domain are the values of x such that the x's are in between 0 and 8. So you find your values mentally or just by visually looking. The lower one goes on the left, the variable you're working with goes in the middle, and the upper one goes on the right. And then you just use less than or equal to symbols in between to indicate that the value is in the middle of those two values. So then we do the same thing for range. Squiggly bracket, the y value for the dependent such that the y is in between the 2 and the 5. So let's practice that again for the example that's listed on the right. So for this graph, if we think about it horizontally, it's traveling in between the values of -6 to 6. So for the domain, we're going to do a squiggly bracket for x, because that's still our variable, such that -6 for x to 6. Now we do the range right next to that, or right below that. And we've got the y value for the range, such that, and it looks like if we look at the graph vertically, it's traveling from 0 all the way up to 6. So we're going to say 0 is less than or equal to y, which is less than or equal to 6. Continuing on here for word problems, typically the domain and the range are very specific numbers. And for equations, the domain and the range are often much more general. And there's a whole graphic that explains this on page 29. So to help students with the specific and general ways of writing the domain and the range, they're not always going to be in inequality form like this. Sometimes the domain and the range end up being words. So some of the words that you would be using are laid out for you in this graphic. Sometimes the domain and the range are best described as all real numbers. All real numbers represent pretty much any number that students can imagine or think of. If the range or the domain happens to be just fraction numbers only, then you would describe either the domain or the range as being the rational numbers. Anything that can't be written as a fraction is considered an irrational number. Non-repeating decimals, square root numbers that are not perfect squares, and numbers like pi tend to be the most common irrational numbers that we find. Rational numbers can be classified further as integers and non-integers. Integers are whole numbers and their opposites. So if you get a fraction and it doesn't turn into a whole number or a negative whole number, then it's considered a non-integer. For the most part, we don't use that label, we just stick with either rational or irrational. The integers are whole numbers and their opposites, so obviously there we can deal with whole numbers and negative numbers. The whole numbers can be classified or simplified further into the natural numbers when 0 is excluded. So it is possible for some students to write the domain and the range as all reals or positive rational numbers or even integers or other types of answers of that nature. So let's do a little bit more practice with domain and the range as it relates to 3 graphs and 1 equation. It's very important as you look at the first graph here. The first graph ends. There is a mistake on graph B. This should have an arrow on the end. So if you look at the 2 graphs, A and B, A has an endpoint, B does not. And so those will have potentially different answers or results for their domain and the range. So let's put into practice what we've been talking about for domain and range as it comes to this first example. If we look at the domain on this first one, we would want to use the width of the graph. There is no variable indicated, so we'll just assume that they mean x. And it looks like it's going from the y-axis all the way out to about 5. So the domain here is going to be for x such that 0 to 5 for x. Vertically, for the range, looks like the lowest that the graph gets is 5 on the y-axis, and the highest it gets is 20. So for the range, we'll say y such that 5 to 20. Now let's modify those same answers when we write the values for b. Because there's an arrow on the end that indicates that those numbers continue beyond the scope of the graph. So for the domain, and again we'll assume x for the independent variable, the domain starts at 0 and then it will continue past what we can visually see. So for the domain here, we can simply say squiggly bracket x such that 0, because it doesn't turn into any negative numbers at all. And then we can do an infinity symbol, meaning that it continues beyond what we can see. For the range starts at 5, and then again it will continue up forever. So we'll use the y such that 5 goes from y to infinity. You could also describe the domain and the range on this particular example with words. So if you wanted to say for the domain instead, if you wanted to say positive reals, that is allowed for you to describe it that way, because it's the same description, just not in symbol form. Similarly, for the r value, if you want to say the real number is larger than 5, that would also be an appropriate answer. Larger than or equal to 5. Let's look at another type of question, like example C here, which involves only specific dots. So as you look at these dots and try to match them up here with the numbers that are below, it looks to me like the domain, the x values, are very specific. It's only the values 1, 2, 3, and 4. So if we're looking at the domain there, we would list them out specifically. And so we wouldn't need a such that symbol here. We could just say that the x's are equal to 1, 2, 3, and 4. And so because it's a list, we can just separate them with commas. We would not include numbers in between, so we wouldn't want to write that 0 or that x goes from 1 to 4 with the inequalities like we've done previously. The reason is if we wrote it this way, it would include all the decimals in between as well. And we don't want these dots connected in any way, which would include decimals. So this would be an incorrect way of writing this particular domain. For the range, you can kind of see on the graph here that the only y value is the 10. So we would just write it and put it in the brackets. The last one here for example D is not a graph at all, it is an equation. So if you have your calculator handy, you'd want to go ahead and make a graph of that so that you could turn it into one like the previous example. Hopefully students are fairly aware of what this graph would look like. X squared is going to make a parabola shape, and then with the including of the plus 1, what it'll do is it'll shift the graph up by 1 on the y-axis. So if we just make a quick sketch of what that might look like on a calculator, it's probably going to look about like that. So if you think about the graph in terms of its width for the domain is going to go to the right forever because of the arrow, and it's going to go to the left forever also because of the arrow. So for the domain here, we could simply say all reals, and we would not have to include any type of bracket or inequality symbol. For the range, you want to be especially careful here because the lowest that the graph gets is to this 1 spot because of the inclusion of the 1 in the equation. So when you write your range on this one, you'd say y such that, and you would say y is greater than or equal to 1. You could also start with the 1 and go to infinity. So another option here is for you to say y such that 1 is less than or equal to, let's make the such that a little bit larger there to distinguish it from the 1. And then the y would go to infinity after that, indicating that it's going beyond the 1 forever.